Hey everybody, so today we're doing 1-3. We're going to split it into 2 days. So day 1 today, and we're talking about real numbers and the number line. So today we actually have 2 essential questions. First one, how do you decide if a number is rational or not? And then, how do you use perfect square roots to estimate the value of non-perfect square roots? There should be an S there. So our objectives, we're going to classify, graph, and compare real numbers, and we're going to find and estimate some square roots. So your job is to get this all written down. Make sure you're taking your essential question, putting it in there, and again, pause as needed. So the first thing we need to know, a number A is a square root of a number B if A squared equals B. So really, in numbers, that means 7 squared equals 49, so therefore, the square root of 49 is 7. So in this little thing right here, we've got some stuff going on. A, the number underneath that radical symbol, so the radical symbol kind of looks like a check mark. The number underneath that is called a radicand. So those are just good vocabulary for you to know. The radicand is under here, the radical is the sign. So what I would like you to do real quick in your notes, as big as you would like, would you please draw a clock? And then I want you to think, either you can picture my clock in your head or think back to last year, this year. What numbers did we have around the clock? And see if you can put so 1 is a perfect, what is the perfect square that goes outside of here? Would you fill that in? And then I'm also, just so you know, we're going to go there. We're going to do 13, 14, 15, 16, all the way up through 20, and then we're going to add 25. So what are the perfect squares that give you those square roots? Pause as needed and quick do this. So now you're back. Here is what it looks like. So we've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. And then would you get these written down over on the side as well? The better you know these, the better off you will be. And so one of the things we're going to do a quiz on this, and we'll do it each day, and you need to pass with 100% and know all of these square roots. Again, if you know them, right, just you can snap them off. It will be so much easier for you to do so many things as we move into the algebra world. So you can have it. I really like this picture because I'm good with clocks. I can look over at the clock and just see those numbers around it. Here's another way to write it. You could do 1 squared equals 1, 2 squared equals 4. You can choose to write these down or not. Either way, you might want to make note cards. You could make up a song to remember them. If you choose to make a song, or you could make a little play, a little video to remember, would you let me know that? Because I would love to use your stuff to share it with other people. And then we're going to go down here and find some square roots. So what's the square root of 81? You got it? It's 9. Then right here, the square root of 9 over 16, so 9/16. The nice thing with square roots, that's broken into 2 pieces. So your answer is, what's the square root of 9? That's 3. And what is the square root of 16? 4. So it's like the square root, you can break it into the square root of the top over the square root of the bottom. If they're both perfect squares, that works really nicely. But sometimes you're going to get something that looks like this, the square root of 74. Well, goodness gracious, the square root of 74 doesn't fit on my clock. So I'm going to picture in my head what numbers around that fit. So the perfect square that's bigger than that is 81, and the perfect square under that must be 64, right? So I know the square root of 64 is 8, square root of 81 is 9. That means the square root of 74 is going to be somewhere in between there. So I'm going to think, how far is this? Well, 64 is 10 away from 74, and 74 is 7 away from 81. So the square root is going to be 8 point something, And I've got to decide 8.5 would be right in the middle. So is it right exactly in the middle? No, it's a little bit more than the middle. So I would say 8.6, 8.7 is going to get us there. Either one of those is a good estimate. So I'm going to go with 8.6. You could pull out your calculator and do it, but we're going to ask you just to think and say, okay, it's got to be between 8 and 9, right? How about the square root of 51? And then the square root of 179. So why don't you take a moment to try those out on your own, seeing what I have done here. Let's see, I've got 49, and so that's 7, and 8 is 64. So square root of 49 is 7, square root of 64 is 8. So my answer is going to be 7 point something this time. So I'm going to look. 49 is only 2 away from 51. And 51 is, what, 13 away from 64? So it's going to be a lot closer to 7. I'm going to say, I'm just going to guess like 7.1, 7.2. I think about 7.1 is a real good answer. And then you could grab your calculator and see what it really is. How about 179? That's a little bit tougher, so I'm going to have to go through my brain. I know that the 144 is 12, so 13, that's 169. Do you see how it's nice if you haven't memorized? If you want to make a chart and refer back to the chart, you can do that. But the quicker you memorize them, the better off you'll be. And then the next one is 196. So I know that 169, the square root of that is 13. Square root of 196 is 14. So that means my answer is going to be somewhere in the middle, 13 point, well, this is 10 away. This is 19 away. So this is almost double, so about 1/3 of the way up. So 0.3, I'm going to guess. You can take your calculator and check your work. But really, you're just checking, okay, what does it fall in between? Between 13 and 14. There you go. Next. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to that drummer, right? Real numbers, here, real numbers is any number we're going to work with right now. Rational numbers, natural numbers are your counting, so 1, 2, 3, 4, 5. Whole numbers are the natural numbers plus what? Do you remember? 0. So 0, 1, 2, 3, 4, 5. No decimals in any of these. Integers are the whole numbers plus their opposites, so -1, -2, -10 bazillion. Then rational numbers is where you add anything that can be a fraction and anything that could be a decimal, repeating decimal, or terminating decimal. But irrational are just those non-terminatings, and they just don't ever show a pattern, repeat. And these right here are not on the clock, your numbers that are not on the clock. And then what's one other thing that goes in there? You've got it, pi goes in there. So let's look right here. Here are a couple. Again, if I'm going too fast, you just pause and you draw some pictures. 4. Is that, what's my question right here? My question is, are they rational or irrational? This one, does it end? Yeah, it's a natural number, so therefore it's rational. How about this one? Well, it's a decimal, so it's rational. -0.8, decimal that ends, so it's rational. 1500ths, rational. But now we've got a square root. Is the square root of 2 on the clock? The answer is no, so it's irrational. So we'll practice this tomorrow during class. Couple more things. Terminating decimals. The Terminator terminated stuff. They're decimals that end. So 0.75. A repeating decimal, it repeats. 0.45, 45, 45, blah, 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 blah. Same thing on and on and on. So I would write that as 0.45 with the repeating line. Non-repeating decimal, it doesn't terminate or repeat. Like pi never ends. Square root of 3, if you did that in your calculator, it ends at the end of your calculator, but it keeps going on beyond that. And there's no pattern there at all. So try these. Write these terminating decimals as a fraction. What should you do? You try them and then come back. This one, as I look at it, I just say it out loud. That says 45 hundredths. So I go 45 hundredths. Can I simplify it? Yes. 5 goes in there 9 times. It goes into 100. 20. Done. And 875 thousandths. Tenths, hundredths, thousandths. 875 thousandths. What goes in there? 25 goes in there. And you might notice, you might know this one, 0.875 is 7/8. So I'm going to expect that you can rewrite those as fractions. But what if it's a repeating decimal? Well, those, find the decimal place where the number repeats. Right there, 56. Right. Oh, find the decimal place where it repeats. So that's the tenths, the hundredths place. Right? So the 56 is going to go on top. And then, since this is the hundredths place, I do 99. There is a good long algebraic explanation for why this works. I'm going to choose not to tell you all about it. If you really want to know, Google it. It's a cool explanation. But for me, this is one of those things that I just choose to believe it. Can I simplify? I cannot. 56 over 99, nothing goes into both of them. So let's try a couple more. You try. 0.612, 612, 612. Try it real quick, pause, and then come back to me. All right, 612 is what I've got. Tenths, hundredths, thousandths. So I go 9, 9, 9. Now this one can simplify. How do I know? 6 plus 1 plus 2 makes 9. So that means 9 goes into this. And because I already did my notes, 9 goes in here 68 times. Goes in here 111 times. We'll practice some of this, but I just want you to see the concept, and we'll go from there. 2 things to remember. If you add or subtract a rational number and an irrational number, you'll get irrational. So if there's any irrational in there, it's all irrational, just like an argument with an irrational person. If you multiply or divide a rational number and a rational number and an irrational number, you get irrational. Same thing. One irrational makes the whole place irrational. So there we go. This video might have been a little bit longer, a bunch of stuff to write down. But I want you to have that all in. Tomorrow we'll come back to class and we'll talk about it. See you then.